In this video, we will go over the exercise questions for work and energy. I think there are close to 20 odd questions, and we'll see if we can cover this in one video, less than 20 minutes. If not, we will split it into two videos. So let's start with the first one. Look at the activities listed below. Reason out whether or not work is done in light of your understanding of the term work. Okay, so our understanding of work is, work is force times displacement, and displacement is in the direction of the force, right? Only then we consider work to be only then we consider work to have been done, right? And if we expand this expression, force can be replaced by mass times acceleration times displacement. So the displacement has to be greater than zero for work to be done. Right. So Soma is swimming in a pool, swimming in a pond. So of course, Soma is moving from point A to point B, and which means that your displacement is greater than zero. So Soma is doing work from a science, from the definition of work in physics. A donkey is carrying a load on its back. It's not said that the donkey is walking, so we'll assume that the donkey is at rest. So there is some load on the back, and it is just standing at some point. So it's not moving. So there is no displacement. So displacement is not not zero since the donkey is at rest. So it's not doing any work. A windmill is lifting water from a well. A windmill is lifting water from a well, which means that the windmill is is pulling water from a well, which means that the water is moving certain distance up, right? There is a displacement of there is a certain displacement, and which means that the windmill is doing some work, right? So because displacement is greater than zero. A green plant is carrying out photosynthesis. So a plant carrying out photosynthesis is not moving, right? It's doing it internally, but it's not moving. So there is no displacement. So there is no work that is done. An engine is pulling a train. Obviously, when an engine pulls the train, it moves. The train moves along with the engine, which means that there is displacement, so there is work done. Food grains are getting dried in the sun. They get dried. Yeah, you see food grains getting dried in the sun, but the food grains don't move, so there is no displacement, so there is no work done. Sailboat is moving due to wind energy. Yeah, because it says the sailboat is moving, which means that there is work done. Right there, because there is displacement. Second question, an object thrown at a certain angle to the ground moves in a curved path and falls back on the ground. The initial and the final points of the path of the object lie on the same horizontal line. What is the work done by the force of gravity on the object? So let's take the example like this. So the object was thrown from here. Let's consider, it was thrown from here and it took a curved path like this, and then it came back to B. Right. Let's say that probably it reached a certain height of h, and then it came back to B. We know that the expression of work is a force times the displacement in the direction of the force. Right. So the question here is what is the work done by the force of gravity? And we know that the force of gravity operates in this direction, right, perpendicular to the surface of the earth, right? So relative to the perpendicular to the surface of the earth, what is the displacement of this particular object? The displacement is zero because the object was thrown from point A and it came back to point B, and both of them are at the same level, right? So the displacement in the direction of gravity is zero. So S is equal to zero, and so the work done by gravity is considered to be zero here. A battery lights a bulb. Describe the energy changes involved in the process. So we know that we can say that the chemical energy in the battery gets transformed into electrical energy, and that electrical energy would light the bulb, and I think it will also get transformed into some level of heat, because if you touch the bulb, you will find it hot, right, after some time. So which means that your electrical energy, you get light from the bulb, plus there is also some amount of heat that is a result of the electrical energy. So the transformation is chemical energy to electrical energy, and this electrical energy goes into either, mostly it goes into light, and some part of it is transformed to heat. Certain force acting on a 20 kg mass changes its velocity from 5 meters per second to 2 meters per second. Calculate the work done by the force. Okay. So the mass of the object is 20 kgs, and u is the initial velocity is 5 and the final velocity is 2. So the work done by the force, right? So the work done by the force is nothing but the energy, right? The energy it acquired as a result of it, right? So we know that let's calculate the kinetic energy. I mean, we know that work and the energy are the same, right? So work done by the force, work done by this force between the changes. If you calculate the because it is in motion, we can calculate the kinetic energy of that particular object. If let's calculate the kinetic energy of this object when it was traveling at 5 meters per second, and we can calculate the kinetic energy of this object when it was traveling at 2 meters per second, and the difference between that kinetic energy should be the work done by that particular force, right, between this transition. So kinetic energy when it was traveling at 5 meters per second is half times m times 5 square, and kinetic energy when it was traveling at 2 meters per second is half times m times 2 square. So your net work that is done is half times 20. 20 is the mass times 4 minus 25, which is minus 210 joules. The reason it is negative is because there is a negative acceleration here. It is slowing down, right? So since the acceleration is negative, the net force is also negative. Okay. A mass of 10 kg is at point A on a table. It is moved to point B. If the line joining A and B is horizontal, what is the work done by the object by the gravitational force? Explain your answer. So the mass of 10 kg is at a point A on a table. Okay. So let's say this is a table. The table is at a certain height h from the surface from the ground, and we say that it is moving at a point. The line joining A and B is horizontal, right? It moves from point A to point B. Since it is horizontal, we know that it is both point A and point B is at the same distance h, right? So there is no additional distance h, and we know that gravity acts in the direction perpendicular to that table, right? And since there is no displacement, right? Even here the height is h, even here the height is h. So since there is no real displacement, so the work done by the object, or the work done on the object by the gravitational force is actually 0, because there is no displacement in the direction of the gravitational force. Question 6. The potential energy of a freely falling object decreases progressively. Does this violate the law of conservation of energy? Why? Yes, the potential energy of a freely falling object decreases. That is true. However, that whatever is the potential energy that is lost is also converted into kinetic energy, because the object starts to move, right? An iron ball that is hanging originally has a potential, has everything as all the energy is held as potential energy, and the kinetic energy is 0 because it has not started to move. But the moment you snap the string and it starts to move, it starts acquiring kinetic energy, and it acquires that kinetic energy only from this original potential energy. So that's why the expression for the total mechanical energy is the sum of kinetic energy plus potential energy. So while the potential energy does decrease, it does result in an increase in the kinetic energy. So the net mechanical energy remains the same, and that is how the law of conservation of energy is conserved. What are the various energy transformations that occur when you are riding a bicycle? We can say that there is a chemical energy in our body from the food that we have consumed. So that, and using that chemical energy, we are able to move our muscles. And that muscular energy is what gets transformed into the mechanical energy of moving our legs and does the cycle moves, right? So it is a transformation of the chemical energy from food into muscular energy into the mechanical energy of moving our legs, of riding the bicycle. Does a transfer of energy take place when you push a huge rock with all your might and you fail to move it? Where is the energy you spend going? Does the transfer of energy take place when you push a huge rock with all your might? So here the rock is huge and you are pushing the rock, which means that you are applying when you are exerting a certain force on the rock, but the rock is not moving because the force you are applying is not sufficient is not sufficient to alter the inertia of that rock, right? So where does we know that law of the conservation of energy is that because you have certainly spent some energy, right? I mean you have spent some energy, which means that you have put in some effort. You have tried to spend some. I mean you have spent some energy, but since the rock is not moving, does it mean that your energy is destroyed? No, law of conservation of energy says that energy can either be created, not destroyed. So the energy that you exert, the energy that you expend through the force that you exerted on the rock has to be transformed into something, and it has transformed into possibly heat energy because after exerting an effort, you would start sweating, right? Which means that your the result of your energy has possibly transformed too. Either the entire thing should have transformed. If you are able to push the rock, it would have transformed into mechanical energy because the rock then moved. All the energy, the only way it would have gotten transformed to is you would have gone tired and because your temperature would have increased and you will start sweating. So it would have transformed the energy that your chemical energy in your body got transformed into your muscular energy, and then that would have transformed into heat energy, and you start to sweat. A certain household has consumed 250 units of energy during a month. How much energy is this in joules? So one unit is considered to be 1 kilowatt hour, and so when we say 250 units, we call it 250 kilowatt hours, and which is nothing but when you say kilowatt, it is if you multiply it by 10 cube, it is 250 into 10 power cube watt hours. And if you want to consider everything in seconds, you've got to replace this whole thing. Replace 1 hour with 3,600 seconds, which is 250 into 10 cube into 3600 joules. This is the total energy that is being consumed, and which is nothing but I think it comes down to 900,000 kilojoules of energy per month. An object of mass 400 kg is raised to a height 5 meters above the ground. What is its potential energy? If the object is allowed to fall, what is the kinetic energy when it is halfway down? Okay, so an object of mass 400 kg is raised to a height of 5 meters above the ground, and we know that the potential energy is mass times the acceleration due to gravity and times h. So it is 40 times 9.8 into 5, and which comes down to 1960 joules, right? Now, what is the potential energy if the object is allowed to fall? What is the kinetic energy when it is halfway down? So when it is halfway down, the object would have acquired certain, out here the object had certain potential energy where the kinetic energy was 0. When it was halfway down, it would have lost certain potential energy, which is what would have transformed into kinetic energy, right? So to calculate the kinetic energy at half point, it is enough if we calculate the new potential energy, and subtract it from the original energy, right, which is 1960. So what will be the potential energy at half the height, which is going to be 40 times 9.8 into 2.5 meters, which is half of 5 meters. So it comes down to 980 joules. So at half point, the potential energy is 980 joules. So at half point, the kinetic energy is the total energy minus the potential energy, which is 1960 minus 980, which is also 980 joules. What is the work done by the force of gravity on a satellite moving around the Earth? Justify your answer. So let's consider this to be the Earth, and you have a satellite that is revolving around the Earth, right? It is going around this direction, it is going around the Earth, and gravitation is always, in the direction towards the gravity is always towards the center of the Earth, right? In a way, it is perpendicular to this point, right? If you draw a straight line here, it will always be perpendicular to this line and towards the center. And at any point, wherever you see the satellite, its direction, the gravitational pull will always be perpendicular to that line that you draw tangential to that particular point, right? And that distance is always the same. If you see in this entire orbit of that satellite, that distance always remains the same, which means that the satellite doesn't acquire any additional displacement in the direction of this force, right? Because at any point in time in this circle, it is always, every point is actually equidistant to the center of the circle, and that is the direction in which the gravity acts. So since there is no real displacement at all, there is no real work that is done by the force of gravity on the satellite. So the work done by the force of gravity is equal to 0. Can there be displacement of an object in the absence of force acting on it? Discuss this question with your friends and teachers. So we are saying, can there be displacement of an object in the absence of force acting on it? Okay. So we discussed that, there are two natural states of an object, right? An object can be at rest or it can be in motion. If an object is already in motion, it will continue to be in motion until its inertia is disturbed. And an object that is at rest will continue to be at rest until its inertia is disturbed through an external action. So a force is only required to alter the inertia of that particular object, right? So a force is not really required for an object to create any displacement, because if an object is already in motion, it will anyways get displaced without an external force, right? So the answer here is yes, there can be displacement of an object in the absence of a force, when only if the object is already in motion, and which is perfectly fine. An object that is already in motion will get displaced in spite of an external force not acting on it. Let's take a quick time check. I think we are possibly close to the 20-minute mark. So we've come till the 12th question. So let's go with the remaining questions in the next video.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.